Wasn't help. Sorry, what team should it have been? Port. Okay, all right. I'll make some improvements in future. Okay. So let's fill in the blanks. Dominance matrices, write that down, are used to rank objects in a network. For example, they could be used to rank players in a round-robin tournament, rank students in a class according to who has the most influence, ranking teams in a sporting context. Dominance. If you think of the word dominance, what does the word dominance mean? If somebody dominates at something, does it mean they're really good at it? Like if one person is dominant over another person, it means they have influence, doesn't it? That's what dominance is all about. Suppose C and D are competing in a round-robin tournament. During the tournament, Bruce defeated Adam, Charlie, and Dinah. Charlie defeated Adam and Dinah. The results can be displayed in this little directed graph over here. B arrow A means B defeated A. Let's write that down. So do you notice that the direction of shows who defeated them? This person defeated that person. All right? We're thinking of winners here. If we let 1 represent a win and 0 represent a loss, or a game that hasn't played yet, then we can construct what's called a connectivity matrix for the network. In this context, we actually call it a, can everyone say those two words? Everyone? Oh, you're feeling alive this morning, Year 12s? Feeling alive? It's a dominance matrix. For the scenario above, let's look at it. So here we go. So we've got our dominance matrix. Now constructing this dominance matrix is the same as a connectivity matrix. It's the same thing. You can see here, look, A defeated D, so we put a 1. See how the A goes to the D, so we put a 1 there? Make sense? What does this person say? We write zeros on the leading diagonal. What does the leading diagonal mean? I'm seeing people go like this. Yeah. The leading diagonal is that dotted line, isn't it? You can't play a game against yourself. So they're always going to be zeros. Add the elements of each row to find out how many direct wins each player had. The best players have the highest numbers. So we add these up. The add is 1, 3, 2, 0. Here's our column matrix over here. Now, can someone explain why are the rankings B, C, A, D? How come? Because that's the order? Because the order from what? Highest to lowest. Good, over here. B has the highest, C is next, A is next. Yeah, good. So that's our order there. Are you with me so far? Matrix. You're like, now let's consider something different. Let's consider a 5-player tournament. All right, we're looking at 4 players now. Can we look at 5 players? Here's our 5-player tournament. There's all the people playing. There's the directed graph. You with us so far? We've got our dominance matrix here. Remember, a dominance matrix is pretty much just a connectivity matrix. It's just called D instead of C. Okay. Got all of our wins. We've got our row sum. So you add the rows. But in this case, the rankings are C is clearly best, but then A, D, and E are all equal second, aren't they? And B is clearly last. Now it's not really saying A, D, and E. So use matrices, sometimes consider D squared. Let's have a look at D squared here. So we might have a look at D squared. So if we have a look at D squared, and remember how matrix multiplication works, when we look at this number 2 here, where that 2 comes from is we get every element in the last row and we multiply it by every element in the first column, and that gives us this 2. So a little bit more information about who's possibly better. The 2 is a result of E defeated B and B defeated A. So that kind of shows that E is dominant over A. All right. E beat C and C beat A. To flip it to an example here, we've got Josh next to Noah next to Brad. All right. Suppose, okay, and Josh defeated Noah, and in another game Noah defeated Brad. Who do you think would win between Josh and Brad? Why? Because you beat Noah, all right? So you've kind of got, and what we would say is you've got like second order dominance over Brad, really. We don't know, maybe Brad, like at the Aussie Open this year, did you see that match? Wasn't it 2 sets down and 1 in 5 sets? Was that the final where it was a 5-set win? Okay. But you know, we'd predict that, okay? So sometimes you've got a second order dominance. Kind of more useful in sporting contexts, don't we? You know, like if we're thinking of that context, yes, Josh beat Noah and Noah beat Brad. We could kind of say that probably Josh is going to beat Brad, but we don't know for sure, do we? So second order wins aren't really as useful in predicting outcomes, are they? We should probably give them less weighting. So when we do what's called a supremacy matrix calculation, can everybody say supremacy matrix? All right, maybe you're thinking of supreme pizza, okay? Supremacy, like supremacy, thinking there's that movie, The Bourne Supremacy. Have you ever seen The Bourne Supremacy? All right. It's like if you're really supreme, it's like ultimate, isn't it? The matrix S supremacy matrix D plus half D squared is often used to help sort equally ranked individuals. So if on your original dominance matrix lead to teams being equal, you use the supremacy matrix. And notice that we put half there because, now I'm going to give you a chance to write this down, its purpose is to reduce the second order influences when added to the first order influences. We want to reduce the second order wins. They're not as important. I'll let you copy that down. Now in this example, back on that 5-way tournament, when we calculate D plus half D squared, we get that answer, and then we add up the rows. So you add up all the values in the rows, and this is our result. What do you notice about the row sum now? What do you notice? There's fractions when you do a supremacy matrix, because we've multiplied by a half. What else do you notice about that row sum? D wins. C's the ultimate. Originally when we did this ranking up here, C was the best, and A, D and E were equal second, and B was last place. Flynn, what do you see about the rankings now? They're different, aren't they? So, A and E are still equal, aren't they? Done. Like they're still on 4 points. But we've now been able to split D is not as good as A and E. All right, so we've been able to do some splitting here. Ideally, we'd love them to be all equal, so maybe we'd need to go to third order influence. Spoiler alert, let's look at that on Monday, okay? What's the little comment that we've got there? We often give D squared half as much influence as D, influences of lower significance compared to that first order influence. In that formula, we can half as much influence. All right, we're reducing that. Should we have got a question? Grab out your calculators because we're going to need that today. And is that limitations? Is that what question you've got there? All right, discussion. What are some of the limitations of using dominance matrices to rank individuals? What do you think? What are some of the weaknesses of this method? Should we come back to that? Can we come back to that? Let's look at an example and let's come back to that question. All right, maybe you'll think of it as we look at this. Let's look at Alan, Bob, Colin and David, who are playing in a round-robin table tennis competition. Good on them. This directed graph shows their results drawn below. Right, first question. Find the dominance matrix D. What is our size of our dominance matrix going to be? 4 by 4, correct. Remember, we look at each row. On the diagram here, we can see that A defeated D and A defeated B. So that's why I've put a 1 there and a 1 there, and the others are 0 in that first row. All right, happy with that? Question B, can the players be ranked using D only? How do we rank them? What do we need to do? We need to add up the rows, don't we? So let's add up the rows. The row sum is 2. What are the other numbers of this column matrix going to be? 1, 2, and 1. Because we just add up each row. Good. All right, so we do our row sum. So who's best? A and C. So Alan. So first is Alan and Colin, and the other two. Now, this is this funny thing about sport. The others aren't really second, are they? Would you say they're actually third? So you know, in the Olympics, if like 2 people win a gold medal, no one gets silver. That's right, isn't it? So if like 2 people come first, then the next person is third. All right. So, you know, just like in the Olympics, likewise, if like 2 people got silver, then there's no bronze medal given out. All right? So can the players be ranked using D only? No. Surprise, surprise, we're now going to need to find S. What does S stand for? Supremacy matrix. Good remembering. Find that matrix and use it to fully rank the players. Let's do that on our calculator, hey? Let's punch that into our calculator. I got that answer. Do you agree? We have some agreements. All right. And it says, and use it to fully rank the players. Let's pick us up. Owen, what am I going to need to do to rank the players?
You just
Add them up. Yep. Add up each row. Happy with my row sum there? I got 3, 2, 3.5, 1.5. How's my mental maths for Friday? Pretty good. So let's rank them. So first would be C, second, A, third, B, fourth, D. Right, so we've fully ranked the players now. Happy days. Predict the outcome for the next time Alan plays Colin. Talk to your neighbour. I want you to talk to your neighbour. I want you to make a prediction and I want you to give a reason for your prediction. Go. Have a chat to your neighbour. Who would win? Tell me why. All right, I'll give you 5 seconds to wrap up your reason. 4, 3, 2, 1. So, in the hot seat, who would you pick and why?
I think maybe Alan, because Colin only won by 0.5, so maybe he'll, get upset.
You reckon that? So you reckon Alan because Colin only won by 0.5? Yeah. Okay. Hands up if you disagree. All right, we've got some people disagreeing with this, right? Let's pick something.
Well, Colin is ranked higher than Alan, so I would just say that there's a real chance.
Probably agree with you more there. Sorry, I'm going to disagree with this, Sareem. Highest ranked player, so I would probably predict Colin. Yeah. As he is ranked higher in D plus half D squared. You agree? Probably Colin? But you're right, it's only just. Okay? So, yes, this is making predictions, but maybe at this point, let's go back to the top of the page where we can talk about what are some limitations. All right, see at the top of the page where I had that questions. What's this? Is it a table tennis competition? All right. Now let's think of some real life things that might affect, because this is just matrices and it's only looking at one previous game. So what are some limitations of using this matrix method to make future predictions? What are some downsides of this? Let's be a little bit critical of ourselves here. Can I kick us off with one? Maybe the conditions might change for the next match. Maybe these previous matches were all indoors and now this next match is going to be outdoors. Maybe Alan is actually better playing outside compared to inside. So I guess, will the conditions change? Right, so that's possibly a limitation, all right? What's another limitation you reckon you could add to our list? Yep. Yeah. Might be maybe injury.
Next question, can you just make up anything and get points? Like, can you just say, oh, well, you might have had a rough night last night, so...
No, it's before. Pretty much. Yeah. Okay. Yeah. A limitation. Short answer, yes. Okay. Short answer, yes. Short answer, if this was a question in a test, I'd want you to put it in the specific context. Okay? So don't just write injury, full stop, but talk about it. Like, maybe there could be this. Let's think about it if it's teams. Can we think about teams? If you're using it to rank some teams in like footy, like for example. What would be some limitations of using matrix methods to make predictions for future team performances? Yeah, different players, different matchups, yeah. Players may change. Have you ever heard one of those superannuation ads where at the very end they say past performance does not always indicate future performance? Like there's a bit of a disclaimer. Yes, past performance sometimes does influence future performance, but it's not a certainty, is it? Right, so we're going to see more of these along the way, that there's some limitations to this. Like, the more data you have, do you reckon, like this is only just one match, like one previous match. The more games that we have, possibly the better.